Hi students, my name is T. Rajshekhar, working as a lecturer in civil engineering, SRRS GPT Sirsilla Polytechnic College. So this is for the Diploma in Civil Engineering, third sem, second year students. We are going to discuss the subject is Engineering Mechanics. So today's topic, forces and moments. Okay, so in the previous videos we have discussed the forces, and in this class we are going to see the our various statistics of forces. On completion of this class you will be knowing the characteristics of force, okay, and principle of transmissibility of force, and distinguish between coplanar and non-coplanar forces, and classifying the coplanar forces. So once we recap, that is, force is that which changes the state of rest of the body or the uniform motion of the body in a straight line. So this is the definition of a force. So force is also a vector quantity. A vector quantity possesses both magnitude and direction. So two or more forces acting simultaneously on a body constitute a system. So that is regarding the force. So we have seen the characteristics of forces in a previous class, that is magnitude, direction, sense, point of application. So we have stopped at the previous video, that is regarding system of forces. So we have discussed the regarding the system of forces. It was divided into the force systems, coplanar, non-coplanar, and from coplanar it is divided into the collinear, concurrent, non-concurrent, and from non-coplanar it is divided into the parallel, non-parallel, and from non-concurrent it is divided into the parallel, non-parallel, and from parallel it is divided into the like parallel, unlike parallel. So these are all system of forces. Let us see. The first one is coplanar forces. Okay, so here, forces whose lines of action lie in the same plane. So that means here, the forces whose lines of action lie in the same plane. Okay, these are the forces here. So we can see here a circle was given. Okay, so here the resultant are, and these are the forces F1 and F2. So F1 and F2 force are in the vertical direction downwards, and the R is the center of the resultant, it is in the upward direction. So where the forces whose lines of action lie in the same plane are known as coplanar forces. Whereas coming to the non-coplanar forces, here forces whose lines of action does not lie in the same plane. So these forces which does not lie in the same plane. Example, you can see a body is given a diagram. So a force is uh, extending towards you outwards, okay, and the another forces 2 are Q and R in the vertical upwards, and the force P is in the downward direction, and T is in the downward direction, and whereas S in the downward direction. Only the R is in the upward direction. So we can observe here the forces are not in the same plane. That means they are not in the same direction also. So they transverse the forces which whose lines of actions does not lie in the same plane. That's why we will say it is non-coplanar forces. So the difference between these two forces you can see, understand by these two diagrams. That means how where the coplanar forces which are acting towards downwards, one force will be acting upwards. Whereas here three forces acting downwards and two forces acting upwards, and whereas one force acting horizontal force. So that's why here these forces does not lie in the same plane. So principle of transmissibility of a force. So here a force acting on a certain point of a rigid body can be considered to act at any other point on the line of action. So here that means you can see a body is there, so the force is acting the B point. Okay, the A is the point of application which shows here, and the P is the force. Okay, which the force is acting the point of application from B, that is the effect of force P is same either at A or at B as per the above principle. So this is the principle of transmissibility of a force. That means a force acting on a certain point of a rigid body so can be considered to act any other point on the line of action. So this is the our line of action which represents the body. So that means from B to A or A to B, the force which is represents here on same line. So that's why whatever the force which is acting, it is denoted as P. So here the principle is at A or B as per the above principle. So next, system of forces. So in system of forces, it is defined that two or more forces acting simultaneously will constitute a system. So here, as we discussed, coplanar forces, that is forces whose lines of action lie in the same plane, that is F1 and F2, which is R. Okay, this is coplanar forces. And in non-coplanar forces, the lines of action does not lie in the same plane, just like this diagram. Okay, so here you can see F1 and F2 both are in the vertical direction, and F6 is in the vertical direction downwards, F5 and F4 downwards vertical direction, and F3 in the horizontal direction, okay, towards right. So coplanar forces are subdivided into collinear, concurrent and non-concurrent forces. So now here in the system of forces above format, so the coplanar forces are subdivided into collinear, concurrent and non-concurrent forces. Okay, so as we discussed, the coplanar forces are nothing but, so they will lie in the same direction. Okay, that means the action lie in the same plane, but non-coplanar forces does not lie in the same plane. Now we are seeing here the coplanar forces, that is collinear, concurrent, non-concurrent. So let us see what are the concurrent forces and collinear forces. So the concurrent forces, coplanar forces whose lines of action pass through a common point P. So you can see a frame type structure it is given. So here you observe the T1 and T2. Okay, these are the points which are given, and W is the a load. Okay, W is the load hanging, and P is the forces which are distributing towards, that is one is going to the T1 and another is going to the T2, and one force is going to the downwards W. So when these three forces which are acting at the same plane, that is nothing but at common point P, it is termed as concurrent forces. So these forces which are taking and acting at one point at the center of point P. This is termed as concurrent forces. And collinear forces, the coplanar forces having same line of action. So these are the forces we can see F1, F2, F3. And here you can see F3, F1, F2. So here F1, F2, F3 forces are acting in one line, whereas F3 and F1 and F2. So here F1 and F2 are in the opposite direction. Okay. So F3 is in the forward direction. So here the forces which are acting in different directions, but they are in line of same action. That is the collinear forces. And the next one is non-concurrent forces. So the confluent forces whose lines of action do not meet at a common point. So here the diagram was given. A body that is A, B and C was there. So here F1 is the force which is acting downwards, and F2 and F3, here F2 is in the horizontal direction, whereas F3 is in the inclined direction. So that means these are coplanar forces whose lines of action do not meet at a common point. So they are acting in different points. So they cannot meet at any point. So these are known as non-congruent forces. Suppose points of application are different for three forces, that is A, B and C. The next see coplanar parallel forces. So let us see the coplanar parallel forces. Here these coplanar forces whose lines of action lie in the same plane and parallel to one another. That means here you can see R1 and R2, the two forces which are in the upward direction, and W is the center of the load which is acting. So R1, R2 and W are the parallel forces. So these are called vertical or parallel forces. They lie in the same plane. Okay, so they lie in the same plane. This is the plane, and they are parallel to one another. So that's why we will call it as coplanar parallel forces. And the next we can see coplanar non-parallel forces. So meanwhile in the same direction we have seen, that is coplanar forces. Now like that we can see the coplanar non-congruent forces. So here the lines of action of forces in this system lie in the same plane but not parallel to one another. So here the lines of action of forces in this system, they are lie in the same plane but not parallel to one another. That means here you can see F1 and F2. These are the two forces which are acting on the plane R1 and R2. Okay, so these forces which lie in the same plane but not parallel to each other. So in the previous, the forces are coplanar parallel forces are parallel to each other like this. So if the one force is acting upwards and the right side is also acting, but center force is acting, so they are opposite to each other. But here they are not parallel. One force is going upwards, okay, another force is going upwards, but two forces are going in inclined direction. So that's why Here they are not parallel to one another. It is termed as coplanar non-parallel forces. And next, coplanar parallel forces are further divided into like parallel forces and unlike parallel forces. So, coplanar like parallel forces are: in this system, lines of action lie in the same plane parallel to one another and have the same sense. So here these coplanar like parallel forces are, they will be lie in the action of same plane parallel to one another and have their same sense. So here you can see F1, F2, F3, F4. So they are commonly parallel in one another, that is they are acting all downwards forces. So that's why we will call coplanar like parallel forces. Let us see now coplanar unlike parallel forces. So in unlike parallel forces, in this system, the lines of action lie in the same plane parallel one another and have opposite sense. So here these lines of action lie in the same plane parallel to one another, but they have opposite sense. So here you can see F1 is in the downward direction, F2 is in the upward direction. So that means the both are parallel upwards and downwards, but they have the opposite sense. The arrow mark which is terms, you can see this is our sense. Example, forces F1 and F2 in the above figure. So these are the our coplanar like and unparalleled forces. So now we have seen the forces which are in the half of the part. So let us see the another upcoming forces. So now we have discussed the topics today: characteristics of force and different systems of forces. In this session, coplanar and non-coplanar forces and parallel and non-parallel forces, like and unlike parallel forces. Let us see, continue the other forces also. So let us see the now from forces and moments, that is resultant and equilibriant. So objectives, now you will learn define resultant, equilibrium and equilibriant. So determine the resultant and equilibrium for a given system of forces. So in the previous we have seen that force is that which changes or tends to change the state of a body, and system of forces, two or more forces acting simultaneously on a body will constitute a system of forces. So that is forces whose lines of action lie in the same plane are coplanar forces. So can we replace different forces acting simultaneously on a body by a single force to achieve the same effect produced by the system? So can you understand here? So can we replace different forces acting simultaneously on a body by a single force to achieve the same effect that is produced by the system? Yes. So let us see here. Resultant of forces. Single force that can replace a system of forces acting on a body to produce the same effect. That means here you can see a 30 newtons and a 70 newtons is there. So one force is extending towards point A, suppose, and this is a point B, and one force is extending towards B. So hence the load and the contraction which appears on this body at the center of this position. Okay, so another one, the force, you can see one force which is acted at 40 newtons. That means if you do minus, that is 70 minus 30, you will get 40. So that is called resultant. Means from this, half of the load which is there, the 30 newtons load, if you replace or you remove it, so then you will get the load as the 40 newtons as the resultant. So here, when several forces act simultaneously at a point in a body, keep the body in equilibrium. Okay, so these are all the several forces which are acting on a point of a body. Okay, but they will be in equilibrium, therefore the resultant is 0. Okay, so this is the point where we will be the 0, because all the forces are acting in the different directions. Okay, these are all several forces. You can see 20 newtons, 45, 70 kilonewtons, 115, 45 kilonewtons, 20, 70, 115. So all the forces are extending towards the outer direction. So in between it will be the 0. So here a system of forces acting on a body is said to be in equilibrium if the resultant force is 0, suppose. Okay, so 50 newtons and 50 newtons at both directions. These are system of forces in equilibrium because the same load was acting here in both sides. Okay, so the same loads which are acting in both sides, both directions, so it is system of forces in equilibrium. So what is equilibrium? Definition: the single force that is to be added to a given system to bring the system to equilibrium. So here the single force that is to be added to a given system to bring the system to equilibrium. So that means here you can see 80 newtons was there and 13 newtons and 50 newtons were there. So 30 plus 50, 80. So whereas here only the 80 newtons was there. So when 13 newtons was acting at one up to one point and 15 newtons at the another point. So these loads which represents it is called equilibrium. So that means these are also system of forces and equilibrium. Next is resultant and equilibrium. So they are equal in magnitude, act in opposite directions, collinear, act along the same line. So these resultant equilibrium are, they are equal in magnitude and they act in opposite directions, and the collinear act along the same line. And here you can see the 50 newtons equilibrium is there. So this is the 30 newtons and 40 newtons, and this is a 50 newtons resultant. Okay, so which the force is acting towards the inclined downward position, this is called equilibrium. Okay, so where the load highly pushes here, 50 newtons is the highest load, whereas 30 newtons is in the vertical direction and 40 newtons is in the horizontal direction. So when the both loads acting here, the 50 newtons load which is acting downwards vertically, so it is the equilibrium. So that means resultant will be upwards and equilibrium will be downwards. So they are in opposite directions but equal in magnitude, means equal loads are there. And next, resultant of collinear forces. So here it is the algebraic sum of the collinear forces acting on a body. So these are the algebraic sum of the collinear forces acting on a body. So forces acting in the same direction to be assigned the same sign. Okay, so here the forces which are acting in the same direction, those are to be assigned in the same sign, and forces acting in opposite directions to be assigned are in the opposite signs. That means, so these forces which are acting in opposite directions, they will be assigned in opposite signs. So positive or negative, it will be there. So let us see the some of the examples, that is problems. So find the resultant of three collinear forces 250 newtons and 200 newtons acting towards right and 300 newtons towards left. So here let us see 300 newtons and 200 newtons, and this is 250 newtons. Okay, so here we have to find the resultant of three collinear forces. One is 250 newtons and 200 newtons acting towards right and 300 newtons towards left. So given system of forces, solution. So assign positive sign to the forces acting towards right. So assign negative sign to the forces acting towards left. So this is the principle we have seen. So resultant of the collinear forces is equal to algebraic sum. So there is here in the, you can see 250 plus 200 plus of minus 300 is equal to plus of 150 newtons. That is, plus sign indicates resultant is acting towards right. Okay, so here we can see 250 plus 200 newtons, these both are right. So minus of 300 newtons, we will get 150 newtons. That is, plus sign indicates is the resultant is acting in the right direction only. So this is the direction we have to show. Okay, so 150 newtons from 300, it is in the right direction. Next one, example 2. Find the equilibrium of three collinear forces 200 newtons and 150 newtons acting towards right and 250 newtons towards left. So here, as per the question, we have to draw the diagram compulsory. So 250 newtons is in the left towards and 200 newtons and 150 newtons towards right. So these are the given system of forces. So solution, so we have to assign positive sign to forces towards right and assign negative sign to forces towards left. Okay, next, resultant is equal to algebraic sum of collinear forces. So that means equilibrium is equal to minus resultant. That is, resultant is equal to 200 plus 150 plus of minus 250. Okay, so how the diagram is there? So we can draw here the diagram also. So this is the diagram. So here the 200 newtons and 150 newtons are acting towards right. So one is, this is 200 and this is 150, and the another one is 250 acting towards left. So here 200 plus 150 minus of 250. We will get 100 newtons. So if you get this 100 newtons in minus, then the negative sign indicates that the equilibrium is acting towards the left. So this is a diagram. Here you can see the 100 newtons equilibrium is direction in the left direction. So and again 100 newtons is in the right direction. So here this is equilibrium, this is resultant. So like this we have to do the problems. So let us see here now how to find the resultant of two non-collinear forces. So that is analytically parallelogram law of forces. So here is the another topic, that is graphically triangle law of forces. So we can find the resultant in the non-collinear forces, that is by the analytically we will use the parallelogram law of forces, and in the graphically we use the triangle law of forces. So here by parallelogram law of forces we can find resultant of the two non-collinear forces acting at a point. So here we can find the resultant of two non-collinear forces which are acting at a point. That is, those are parallelogram law of forces. So it states that if two concurrent forces are represented in magnitude and direction by two adjacent sides of a parallelogram drawn through a point A, their resultant can be represented in magnitude and direction by the diagonal of the parallelogram drawn through A. So here in these parallelogram forces, if the two concurrent forces are represented in magnitude and direction, okay, so by two adjacent sides of a parallelogram drawn through a point A, their resultant can be represented in magnitude and direction by diagonal of the parallelogram that is drawn to at A. Explanation. So consider two concurrent forces, that is P and Q. So draw side AB such that its length represents the magnitude of P to a scale and direction same as that of P. So here we can see the P which represents A and B, that is vectorial representation of force P. So this is a side AB drawn, okay, such that its length represents the magnitude of P to a scale and direction same that as of P. So P is in which direction? The A to B is also in the same direction. So these are the directions. We can see similarly draw side AC to represent Q in magnitude and direction. So this is a first we have drawn AB, okay, then after we have to draw similarly AC, that is the in the previous P represents the magnitude and here Q represents the magnitude, okay, and next the parallelogram is completed by drawing other two sides as shown. So here this represents the parallelogram diagram. So A and B, two directions in the x-axis, and A and C, that is in the y direction, okay. So here Q and P represents the magnitude of the direction and D is the meeting point of the parallelogram. So diagonal of the parallelogram AD passing through A represents the resultant R in magnitude and direction. So wherever the AD is there, that means this is the A and this is a D. So from these, the point which is represents to the point D, okay, so this point represents the resultant R, okay, so that is drawn. This is the point R, this is our resultant R direction. So meanwhile, vector AD represents the resultant R, and this is alpha, the angle which is between the P and Q, and alpha is angle made by the resultant with the force P. Okay, so from the previous figure it can be derived that magnitude of the resultant, that is R, is equal to root of P square plus Q square plus 2pq cos theta. Okay, so here the P square plus Q square plus root of 2pq, whereas we are having two sides, one is P and 2, that is Q, 2pq, and the alpha angle which is present, it is cos theta. So here angle made by resultant with P is given by alpha. To determine the alpha is equal to tan inverse of q sin theta by P plus Q cos theta. So it is the adjacent side by A plus B opposite side. So here alpha is equal to tan inverse of, we can represent by q sin theta by P plus Q cos theta. Therefore, in special cases, suppose when two forces P and Q are acting perpendicular to each other, suppose, okay, that is theta is equal to 90 degrees. If R is equal to root of P square plus Q square, since cos 90 degrees is equal to 0, whereas alpha is equal to tan inverse of Q by P. Okay, so since sin 90 degrees is equal to 1, therefore cos 90 degrees is equal to 0. So here we can see the representation P and Q. Okay, this is our resultant R, and if it is in the perpendicular direction, it represents the 90 direction, and it is the alpha angle. So here, when two equal forces P acting at point R perpendicular to each other, therefore Q is equal to P and theta is equal to 90 degrees. That means magnitude of resultant R is equal to root 2 of P. So here we can see, that is in the direction, this is P and this is the Q. So here resultant represents the root 2 of P. If the two forces represent, that is two equal forces are there, suppose, therefore Q is equal to P, that is, and theta is equal to 90 degrees. Therefore angle of resultant with each force is equal and is given by alpha is equal to 45 degrees. When two concurrent forces acting in the same direction, that is theta is equal to 0 degrees. So here P and Q It represents R is equal to P plus Q. So for resultant has the magnitude of sum of the forces, that is R is equal to P plus Q. Therefore direction of the resultant is along the given forces, since theta is equal to 0 degrees. So therefore where two concurrent forces acting in the opposite directions, theta is equal to 180 degrees, therefore P is greater than Q. So here Q is in the left direction, P is in the right direction. Here the resultant where the R to get R is equal to P minus of Q. So then you will get the direction of P. So resultant as the magnitude of difference of the forces, that is R is equal to P minus Q. The direction of the resultant is same as that of the larger force. So finally summary, we have seen today parallelogram law of forces gives the resultant of two coplanar concurrent forces and magnitude of resultant. Okay, so have a nice day. Thank you.